How many solutions are there to this equation? The first thing I decided to do was make it so they got the same base. 4 is 2 squared, so this will be 2 squared to the power of sine squared. And when you deal with like x to the a to the b, you just times them together. So it's going to be 2 to the 2 sine squared x. And that's equal to 1. I actually wrote it as 2 to the 0 and then subtracted the powers and then equal. So let me do, I wrote 2 to the tan squared x minus 2 sine squared x equals 2 to the 0. And from that, we can just equate the powers. So tan squared x minus 2 sine squared x is 0. So tan squared x is 2 sine squared x. You could alternatively, and this is how some worked answers do it, multiply through by this one and then equate them. Look, it's going to be this, you're going to get to the same place. Okay, to deal with this, I'm going to replace tan by sine over cos. So sine squared x over cos squared x is equal to 2 sine squared x. And then I'll multiply through by cos squared. And you've got two options at this point. You can either cancel out the sine squareds, but remembering that you do have to think about sine squared equaling 0. And then we'd also be left with 2 cos squared x equals 1, so cos squared x would equal a half. Or if you're the sort of person who forgets to consider it equaling 0 when you divide through by it, then what you can do instead is minus. Let's get them all on one side and then factorize out. And you'll get the, oh, that should have been a 2. You get the same solutions that way. Either this is 0 or this is 0. So if sine squared x is 0, that means sine x is 0. Let's take a look at what that gives us. We're looking between 0 and 2 pi. So we are going to get 1, 2, 3 solutions. Then from my cos squared x equals a half, I'm going to get cos x equals square root of a half, or 1 over root 2, or minus 1 over root 2. So for the positive one, I'm going to get 2 solutions. And for the negative one, I'm also going to get 2 solutions. Which means in total, there are 7 solutions. Well done.